Okay, I'm going to make another video over combining random variables. And the one I did before was when we were dealing with a y minus x. So we've dealt with a y minus x. In class, we dealt with an x plus a y. In class, we also dealt with a 9x, which means x, keep going. I'm going to do another one similar to this one. It seems like people struggle with these more than they do these. Okay, it says, W.J. Uden weighed many new pennies and found the distribution of weights to be approximately normal, with the mean being 3.11 grams and the standard deviation of 0.43 grams. What are the reasonably likely mean and standard deviation weights of weights of rolls of 50 pennies? Okay, so now what's happening? I have a capital letter X, the weight of a penny. I do not have a Y, but I'm still combining. I want 50 of these X's. So instead of an X plus a Y like we've been doing in the past, or an X minus a Y, I'm combining 50 pennies together. So I could write it out, ... Well, that would take me forever. So instead, I'm just going to think of it like this, 50x. And I know that the mean is 3.11. So instead of adding the means, because we're combining the means, we can just add them. Just like we did up here, we would subtract them when we did subtraction problems. When we added, we'd add them straight together. I could do it like that, or I could just take 50 times the mean of x. The mean is 350 times 3.11. Now, when I'm talking about up here, these are things we've done in class already together. This one was the strawberry problem, or the speed data problem, which I made another video on. This one was dealing with the credits at El Dorado Community College, with the main campus, and with the downtown campus. And this one was the apple problem. Make sure you're familiar with all of that. Okay, let's go back to the Uden. I'm combining variables. I'm going from singular to plural. Then you know you're combining. I'm going from 1 penny right here to 50 pennies now. I'm finding the new mean. So I just type 50 times 3.11 into my calculator, and I get 155.5. So this right here is the mean of 50 pennies. I do need to know the standard deviation though. And so right now we know that the standard deviation for 1 penny is 0.43 grams. I'm going to go to a new page. I don't want 1 penny though, I want 50 of them. So I'm going from singular to plural. ... Okay, what do I have to do first? Before I can use this formula, I have to check for independence. The weights of pennies are independent. Check. I'm going to take 0.43 squared, and I could do it again, 0.43 squared, plus keep going 50 times, or I could just multiply by 50. That's the same thing as adding it 50 times. 0.43 squared times 50, and now I take the square root of that, and I get 3.04. So my new mean is 155.5. And my new standard deviation was 3.04. And this is for a distribution of 50 pennies. Now be prepared for a question that may say, what is the probability of 50 pennies, 155 pennies weighed more than 165 ounces or grams or whatever they're measuring it in. Be prepared for that question. What's the probability that 50 pennies weigh more than 165 grams? You need to find a z-score. Minus 155 over 3.04. You go to the table or you go to your calculator. If you go to the table, you take that z-score, 165 minus 155, divided by 3.04, which gives me 3.29. You're going to get a very large probability. That's because on the table, now not for you calculator people, those of you who do the calculator, you know how to do it differently. But on the table, that very big number is representing the blue area. I want the other area, so I need to make sure I do a 1 minus. When you go to the table or the calculator and you figure out what you have, your final answer should be, and I'm typing in my calculator now, 0.0005. Is it likely that this will happen? No, it is not likely. Why? It's unlikely because it's under 5%. If you have any questions, please let me know.